All right, so in chemistry, it's really our electrons that are going to be doing things when we form or break chemical bonds. And it's not even all the electrons that are doing this, it's just the valence electrons. Let's see what we mean by that. So again, we've got a little nucleus, and then around this nucleus, we've got these orbitals, which we now know aren't circular in shape, but nonetheless, the analogy still works pretty well. And then these orbitals have a certain amount of electrons in them. I'm just going to draw it like that. However, not all of these electrons are really going to be interacting in chemical reactions. It's just this outermost shell that's going to be reactive, and that's what we call valence electrons. And they're going to be reactive, right? So we're either going to take away electrons from the valence shell, or we're going to add electrons to the valence shell. And then the rest of these inner orbitals, we call these core electrons. And overall, they're just going to be unreactive. They're not going to be all that important to the reactivity of the element. The reason that they're so unreactive is that the protons in the nucleus hold on to them too tightly. So they're too close to the protons, so they're just not going to be reactive. It's really the outermost shell that's going to be reactive. And so if we take a look at our handy dandy periodic table, we really want to think in terms of similarities of atoms, right? So for example, if we take a look at chlorine and bromine, they're in the same column or the same group, and thus they must behave similarly. And the reason that they behave so similarly is the fact that they have the same number of valence electrons. So let's go ahead and draw the, or write out the electron configurations for both. So for chlorine, we can use the noble gas above it, which is neon. And then after that, we get a 3s2 and then a 3p5. For bromine, we get argon is the noble gas right above it. And then we get 4s2, then 3d10, then 4p5. And so all these are all represented by the noble gas. Those are all core electrons. And everything that is not part of the outermost shell counts as core electrons. So for example, all of these are core electrons, and so is this 3d10, right? In this case, for bromine, the outermost shell is the n=4 shell. So the n=3 shell does not count as part of the valence shells. So in this case, the valence shells are going to be the 3s2, 3p5 for chlorine, and then the 4s2, 4p5 for bromine. So those are our valence electrons. And if you note, they both have 7 valence electrons, right? 2 + 5 is 7. And that's how the periodic table works, right? Everything here, everything in the first column has 1 valence electron. Everything in the second column has 2 valence electrons. We're going to skip the transition metals because they kind of do their own thing. Everything in the third column has 3 valence electrons, then 4, then 5, followed by 6, 7, and then 8, right? So you should be able to tell how many valence electrons an atom has based on solely its group that it's in.